Good morning, y'all. Wearing my UGA jersey today. Just kind of mourning the potential loss of college football, and just wanted to encourage you again this morning to think, just like based off like part of my story. A lot of you guys remember when I told you that I had that horrible car accident in Labor Day of 2016, right after me graduating from college. Broke my leg in 10 places. My whole world kind of spiraled out of control. Kind of fell into some kind of like dark times, just mentally, and it really reminded me of what we're kind of going through now, where I was in complete isolation. I wasn't able to drive, wasn't really able to go out and see people because I couldn't walk because my leg was completely metal. But in those times, I really relied on my community and people that I could call and talk to, and just remembered that it will get better, and that, I really held on to something that just said, be still and I will fight for you. And so just know that you have a community of people who care about you, and if you don't, then reach out. We will get through this stronger and better together. It may not be tomorrow, it may not be next week, it may not be this month, but at some point we will achieve and kind of rise above. I miss y'all. Really, really care about you guys, and hope you enjoyed today's lesson. It's brand new content. Here's a quick reminder. So next week I'm going to be pivoting into a different type of Zoom call. So homeroom, third period, you guys are going to be Tuesdays at 11 a.m. Fourth period, you're going to be Wednesdays at 11 a.m. And sixth period, you're going to be Thursdays at 11 a.m. It's going to be a lot of fun. Do a little bit more social emotional learning. We're going to do time for you guys to hang out and connect. And then I'm also going to propose like a little bit of like a kind of like math challenge question. Nothing too intense, nothing of me like actually teaching, just some opportunity to get you guys to think collectively and collaboratively. So y'all know I had to do it to you. I got onto TikTok finally. People have been talking to me about it for honestly like the last 2 years. Both schools I've taught at, and I said no, I would never do it. Jumped on board. So if you want to see some what I think is funny content, I've been thinking of some things. Remember, I got that public relations marketing background. So go ahead and follow me on that account. Gas me up, share things. A lot of people told me they saw me on their For You page. Don't really know what that means, but I'm hype about it. Go ahead and follow me on the account. All right, here's your bell ringer for today. Go ahead and click pause. Pay special attention to the equivalent expressions and the factoring using the GCF. Remember, it's basically undoing the distributive property. Go ahead and click pause in 3, 2, and 1. Welcome back. So for this first equivalent expression, it says f plus f plus f plus f. What do you need to remember about the coefficient when there isn't one there? There's always an automatic 1. So that's 1f plus 1f plus 1f plus 1f, which gives me 4f. This is the distributive property. So we do 5 times x, which is 5x, and then 5 times 2, which is 10. You always keep the sign there. Remember, the sign to the left goes with the number. Hopefully you said it with me. D times D times D times D times D. Compare and contrast this to the f's. One is addition and one is multiplication. Remember, they are very different processes. So repeated multiplication is an exponent. So does D to the power of 1, 2, 3, 4, and 5. Here, we are trying to find the same families. 1a plus 1a plus 1a, 1c plus 1c plus 1c. So we have 3a plus 3c. We cannot combine them because they are not in the same family. This one over here is order of operations. What do I do first? You do your parentheses first, and then you rewrite the question. 9 plus 2. You bring the divided sign down. Then I do my exponents next, which is 81. 5 plus 81 divided by 9 plus 2. I ran out of space. Sorry about that. 81 divided by 9 is 9. So then you rewrite 5 plus 9 plus 2 and you get 14 plus 2 is equal to 16. This says we're write an equivalent expression using the GCF. So remember, GCF is greatest common factor. We should know this by just looking at it, but the GCF is, meaning the greatest common you can do divisor, is going to be 11. So if we take 11 out of 55, so 55 divided by 11 is 5, and then 44 divided by 11 is 4. You factor it by multiplying, so 11 times 5 is 55, 11 times 4 is 44. So that's how we know that we were correct based upon the original expression. And then down here we just have our regular volume questions. So this one is 4 1/10 to the power of, that was a big one, to the power of 3. Or 4 1/10 times 4 1/10 times 4 1/10. Again, I'm going to use my calculator. And you get 68,921 thousandths millimeters to what power? Power 3. This right here is the area of a triangle. So remember, you always want to write down your formula to keep yourself grounded. So area is equal to base times height divided by 2. If you don't remember why it's divided by 2, I encourage you to go back and look at my lesson from last Tuesday. It has a really, really good explanation and some visuals on it. So you do 28 times 8 divided by 2. So 28 times 8 is 224. Divided by 2 is 112. 112 meters squared. And what does that area mean? It means all of the space inside of this triangle. And then now we have our trapezoid, the one that gives most of you guys a little bit more anxiety. So let me try to choose a color real quick. Haven't used purple yet. So you get area is equal to base 1 plus base 2 multiplied by the height divided by 2. So base 1 is here, base 2 is 3, so do 7 plus 3 multiplied by 8, which would be 80, divided by 2 is 40 inches squared. Cool. Comments, questions, reach out at any time. So today we're going to learn something called surface area. And the reason why we're doing surface area is this is one of the coolest things of geometry because it talks about what you can do in the real world with geometry. So this is a company called Z Decals. You can actually Google them and look them up to see that I didn't actually make them up. This is my friend's company from college. They a multi-million-dollar company now, and he started by just making decals and car wraparounds for like SUVs and local companies. So you see like Stevie B's down here, a CPR foundation down here, and then he does a bunch of trucks. Well, in order for him to do a full-blown wraparound advertising for these vehicles, he has to be able to find the surface area of each side. And so he breaks it into composite figures. So for example, you could see right here this is a big rectangle. So he finds the area of the rectangle, and then he also has to do the area of all the other similar parts as well. So it's been a really, really cool business, and we're going to kind of explore this and some other companies that have to use surface area on a day-to-day basis. So this is a bus that my buddy's company worked on for the Houston Texans. So he did the full-blown wraparound for the Houston, Texas bus. It's really, really pretty. It's an awesome, awesome avenue. And what I want you to see is if he flattened out the bus, he took the measurements of it, took the dimensions, and then flattened it out and drew a 2D model of a net that we learned about yesterday. And then once he had that, he put the dimensions down for each side of the net in order to figure out, well, this is the right side of the bus, this is the top side of the bus, the front, the bottom, and back, and so on. So how much space do I need to fill to go from side to side, from top to back, and then he can put the designs on from there based off of what he needed to print. It's a really, really cool company, and we're going to explore how he did that on the next slide. So here's some of the fake dimensions that we have. So you can see that if you look carefully, what I like to do is I like to use a lot of different colors. So if you printed out the slides, maybe get a couple colored pencils. If you're drawing that, click pause. But I would like to find the area of this rectangle right here, which you know is 40 by 20. So that's saying that the space inside of that rectangle, I'm going to change it to green, is 800 square feet. Oops. 800 square feet. Okay. And then this one is, actually all four of these are all congruent. So this is 800, this is 800, this is 800. And then down here, the space inside of this is 20 times 10, because we just found the area of that rectangle, which is 200 feet squared, which this is as well. So now that we've calculated this, we can help Nick and his wife figure out how much material do they need to print or have ready to cover the entire bus, the entire Texans bus. So we would just add all of these pieces together in order to figure out what the surface area is. So we have 800 times 4. If you know that 8 times 4 is 32, then you would just do 8 times 4, and you get 3,200. And then the 200 plus 200 is 400. And you get 3,600 feet squared for the surface area. So what that means is all of the space on that bus, the outside, remember, we're not talking about the inside, we're not talking about the area, but the surface area of the entire bus is 3,600 feet squared. Now, this is one of my favorite shows. It was a custom fish tank show. I think it was called Tanked, and they, like, a bunch of celebrities and athletes would hire these contractors to create custom fish tanks for their office spaces, their music suites. So this is Tyga. He was one of my favorite rappers back in college and high school. He has this custom built fish tank in his music studio. So what I want you to do is I want you to calculate the surface area. I give you the dimensions on the right side. You calculate the surface area, click pause now, and then come back to me and check your answers in 3, 2, and 1. Alright, so the front and the back of this fish tank was 10 feet by 6 feet. So you do the area of 10 times 6, which is 60. Multiply that by 2, because there is 2 different sides, and you get 120 feet squared. The top and the bottom is also 60 feet, so you don't need to redo that math. You can just put the little parentheses and mean repeated. You get 120 feet. And then you get the left and the right sides are 7 by 7 squares, which gives you 49 feet. Add it all together, 120 plus 120 is 240, and give you 289 square feet. Clearly that's not to scale, because that's almost as big as Tyga, but you understand the process. Now this is I'm going to butcher it, your parents are going to laugh at me, but I think it's the Louvre, I'm not really sure, but it's this beautiful, like, square pyramid out in Paris. I did not just definitely pause my video to Google that, but this is like when architects have to create things that are different shapes. They always draw things out with the dimensions. They have to figure out what the base would be, kind of just like the Parthenon field trip that we went on. So what I want you to do is quick pause, figure out what is the total surface area. Remember, the surface area is what we're trying to find for all of these sides, so that we're finding the area of each shape, including that base at the bottom, in order to calculate, like, how much, like, for instance, wrapping paper, or for this instance, it would be how much glass would they need to cut in order to fully plaster each side. Go ahead and try to figure that out now, and come back to me in 3, 2, and 1. Okay, welcome back. It is time to go over the area. So I'm going to find the square first. It's a 10 by 10, which gives me 100. And then we know we have 4 congruent triangles. So all these triangles are the same size and shape, so it's pretty easy here to find the surface area. So the base is 10. And the height is 12. This 13 is here to throw you off. Remember, you ignore it. So 10 times 12 is 120 divided by 2 is 60. Oops, that says 10. Is 60 yards squared. So does that mean the answer is 60 or the answer is 100? No. We have to add them all together. So 100 plus 60 times 4, which gives us 6, 12, 18, 24, so 240. So it'd be 340 square yards. Hopefully you got that right. This next one, it says Jada. The problem spelled it wrong. Jada Adams, shout out to you. Jeada, drew a net for a polyhedron and calculated its surface area. What polyhedron, basically, what 3D shape can be assembled from this net? And Jada made some calculations, mistakes in her calculations. What were those mistakes? Go ahead and click pause, and I want you to see, where did she mess up? This is called error analysis. Really good higher-level thinking questions. So after you studied it, you should have seen, looking at these triangles right here, the base is 3 and the height is 4. So she got that right, that she did 3 times 4 is 12. However, she forgot to divide by 2. So she forgot to divide by 2, so this is supposed to be 6, and this is supposed to be 6. Those are the only errors that I saw, but if you saw some more, then definitely give me a shout and let me know where I made my mistake. And the polyhedron that could be built from this, I think it's called like a square pyramid. Here are 2 polyhedra and their nets. I want you to click pause, and I want you to label all the edges in the net with the correct lengths. So clearly, you know that A goes with A, B goes with B. I want you to label with these numbers, where on the nets do they go? Make sure that you do it correctly. Go ahead and click pause and come back to me in a few seconds. Alright, so if you look here, the 10 is on the long part of the edge. So this is 10. Then you have the 4 for the small part of the triangle, the edge. So this is 4. So the base is 4 here, and this is... And the side lengths are all 13. And then on this side, we're going to look at the long rectangle here. And it says that this little side length is 10. See that the length is 10. Then we have a 4 by 5 here. This would be 10. This would be 10. That would be 10. 5, 4, 4, 5, 4, 10. Cool. 10. I want you to think about other examples where you would need to know surface area in the real world. So one example I have for you is wrapping gifts. So if you ever wrapped a gift before, sometimes you just put it in the center. But what you could do is cut out enough paper for each side of the gift box. So this is one right here. It says Kieran is wrapping this box of sports cards to present for a friend. What do you notice and what do you wonder about this? Do we have all the information that we need? At first looking at it, I didn't think so. But then I recognized that this shape right here is a square. So this side has to be 2 and 5 inches. And this is a rectangle. And so since we know that side's 2.5, that side has to be 2.5. And then what I'm about to draw in purple is a rectangle. So which means this has to be 4. This is 2.5. So how many rectangles do we have in this shape? I know you can only see 2, but you got to think about what the 3D net looks like. So remember, there are 6 sides on here. So there's 6 sides consisting of 4 rectangles that are the same, and then 2 squares. So I'm going to find the area of the square first, which is 2.5 times 2.5, which is 6 and 25 hundredths. Multiply that by 2. And then the area of the rectangle is 4 times 2 and 5 tenths, which gives us 10. 4 times 2 and 5 tenths is equal to 10 times 4, because there's 4 sides. So we have 40 plus 12 and 50 hundredths, and we get 62 and 50 hundredths inches squared of wrapping paper. Here's a challenge question. I want you to list the measurements of 3 different rectangular prisms that each have a surface area of 72 square units. You have to get really creative and think about it, maybe draw some pictures, some models that will help you. But go ahead and post your answers into the comment question if you've made it this far in the video. Lastly, I have a mini project uploaded on my website. It's pretty long. You can do part of it, you can do all of it, but I think you might enjoy it. I found it online. It's kind of interesting and really kind of pushes your concept learning of surface area. Thanks for tuning in, guys. Proud of y'all. Have a good day. Reach out with any questions, comments, or concerns. Remember, my phone number is 770-855-2017. I've had a lot of you guys reach out, ask questions, just say hey. Probably best parts of my day is when I hear from you guys. So definitely reach out if you need it. All right, bye.